What our logical next step would be to go ahead and compile this contract. Now, if you remember, in the package.json, we had already added something like a build script, right? So it's a script that we will use in order to compile this contract, right? So let's go ahead and let's compile it and let's see what exactly happened. So npm run build, right? So let me zoom it out a bit. Okay, so npm run build, and here you go. The compilation process has started. Now that our contract is ready, so we are compiling it, and after that, okay, so let me show out to you. So I'm getting some error here. Okay, it's not an error. It's basically asking me to write a compiler version. Consider adding pragma. Okay, fine. So they're basically asking me to upgrade the compiler version. So I will go ahead and I will upgrade it. So we are now pointing to 0.8.4. Okay, it's already compiled as well, right? So that's great. So even the warning came in, but the compilation happened, right? So basically the warning, they are saying that source code file does not require compiler version. Consider adding proper compiler version, which is 0.8.4, right? So now if you see, as a result of compilation, a new folder called artifacts got created. Now this folder will basically have all the all the details around whatever the compilation detail. Now, if you go back and look at our video, so what we basically discussed was that once the compilation happens, there's two type of files that gets created. One is basically the API, which is the abstract binary interface, and the second one is basically the bytecode, right? So that bytecode is not what we need right now, because what we need is basically the API file in order to use that in order to integrate that to the web front end. So I will still go ahead and recompile. So I've compiled it. Let's check the output now. So our compilation is done. Our smart contract is a very basic smart contract. We wrote just two methods. One is the increment and the get count. And as a result of the compilation, we got this artifact file. Now, if you see in the artifact, that contract counter.solidity, there is something called as counter.json. Right? So this counter.json is what the API will look like. Now, if you compare this counter.json with the counter.solidity that we have written, here we have two methods that we are interested in. So the first method is basically the get count, and it provides you all the information around. We do not have an input, and then what's the output is going to be. And then similarly, we have a method corresponding to increment, right? So increment is something which is basically we are not going to have an output for that. All we are going to do is basically update the state change, right? So this is it about the API. There are other things as well that you might interest on, which is the bytecode, but that's something which you can refer to our previous videos, right? So now, once the counter.solidity and the smart contract is done, what our logical step would be to basically go ahead and do the test cases, right? Test cases for it. So what we'll do is we'll be using waffle and chai in order to write test cases and basically verify our contract. Now, understand that everything on blockchain is going to be immutable, right? And hence test cases become very, very important. And if you go to our package.json dependency, we have a few of the dev dependencies, such as say, Ethereum waffle, right? Ether.js will discuss what basically this Ether library is, and chai is again a basic test framework. Now, these test frameworks, such as waffle, enable us to basically test our smart contract, not with Solidity itself, but with JavaScript. Now, this is something which JavaScript is something which probably most of us are comfortable with. So let's go ahead and let's write down the test cases. Now, what I will do is I will delete this. Okay, so I will delete this sample test.js. Right, so I am going to delete this out, and I will be creating something like counter say .test.js. Okay. Now, in here, what we need is basically two methods. One is the expect, and the other one we need the Ethereum library. So I will quickly get those, and then what we need is basically if you go ahead and if you understand that these import statement such as except, we get it from chai, and the ether from basically hard drive. Now these import statement basically allows us to write down logical blocks, right? That creates a structure for our test, and it also helps us to identify issues when reported, right? So what we'll do is we'll quickly, I've already written down a test case, so I will quickly just walk you through that, right? So now this is what the test case will look like. So let's go one by one. So these are just the import statement, right, to get us the expect and ether, and this is what the logical block would look like. So this expect and ether, we get it from chai and hard hat. Now this ether is something which is injected globally as a part of the hard hat configuration. Now what basically it does and what is use case, we'll see it now. However, before that, what chai provides us is basically some sort of a logical block, like say describe and it. Now these basically gives our test cases more like a natural language use case, where it is easy to understand the test cases that we are basically writing down, right? So we'll describe a function, and then what exactly should follow is what this framework provides, right? So let's go through line by line and let's see what exactly is happening here. So basically, this is what our contract is, which is the counter contract. Now our contract has two functions. One is basically to increment and to get the count, right? So while our contract is deployed, what we'll be doing is we'll be setting some default value to it. So in my case, we'll just be setting it to 0, right? However, what happens with this particular line, right? So where we do ether dot get contract factory dot count, this keyword, which is our contract keyword, right? Which is the counter contract. Now what happens is that basically it instructs ether to look up to our smart contract and create a factory so we can later instantiate it, right? So where does that instantiation happens? Its instantiation happens in line number 7, where what we do is we call counter.deploy, right? Now if I remove the 0, it is basically going to throw me an error. Why? Because our deployment method needs some value to initialize, which is going to be 0 in our case. Now in this particular line, we are basically waiting for it to deploy. Now what happens once it gets deployed? So once it gets deployed, what we are expecting, and this is where the natural language expect method comes into picture, where we are awaiting for it, like after deployment, the value of the get count, it should be equal to 0, right? And similarly, what we are going to do is once deployed, we now be doing a transaction. It's going to be more transaction. So our transaction, which is the increment transaction, will call the counter.increment, and as a result of this particular transaction, which is increment.wait, what we are expecting is that the value that has been initialized to 0 will eventually now will become to 1. Right? So this is all about our test cases. Since our contract is very, very basic, we do not have to really worry about anything else. So let's go ahead and let's see how the this test case works, right? So if you go back to again package.json, so in order to test, we have defined a key test. So this is going to basically execute hard hat coverage for us. So what we'll do is we'll simply go about and we'll run this script npm run test. Okay, let me zoom a bit and let's analyze this. Okay, so I'm getting some error here, cannot find module solidity coverage. Okay, so what we'll have to do is, in order for us to get, say, a proper solidity coverage report, what we'll do is we'll basically add solidity coverage as a dev dependency, which will be in the package.json itself. So let me add that, right? So let me add this. And what we'll do is we'll just do basic npm install. Okay, so this solidity coverage will basically generate a coverage report in the form of an HTML template, so that not only you can see the coverage in the console, but you can also go ahead and can run this basically in the browser and can analyze it folder by folder, right? So it becomes easier for you to have a complete understanding of what all files are basically you have the coverage for. Okay, so let this dev dependency get installed. Okay, so now we are done. So let me run that script again, so which is npm run test. So as I run this npm test, so here the compilation is happening. So it will again by default go ahead and compile, and that's it, right? So let's see what happened, right? So if you see here, we had put down all the console.log statement in the Solidity file, and this is what you see here, right? So the first thing it gave us the network information, which is the hard hat EVM version 2.9.3. The network is basically the hard hat, and this is what we are interested in. So the value of the count was first 0, and the value after increment was 1, right? And this is what gets executed in sequence here. And if you see here, the coverage report that came in, that we have a 100% coverage report. Also, in return to this, we even have something like a coverage that gets created here, right? So you can go ahead, this is basically index.html file, and you can go ahead and you can have the entire report around it. Okay, so now that we are done with the test cases, what we'll do is we'll basically, we'll go through the hard hat deployment. Now, Solidity runs with an Ethereum virtual machine, as we already saw over here. In this case, version 2.9.3. So what we'll do is now that we'll use hard hat task runner in order to deploy our smart contract. Now, these are JavaScript files that are basically executed on demand. So I have already created a script for us. So what I will do is I will quickly paste that out, and we will do a basic local deployment as well. Okay, so now again, what I will do is I will delete the sample script.js, and I will create something like a counter.js, right? So script, and then it's going to be simple counter.js, and here you go. Now this is pretty basic, common to almost all the project. All we have to be interested on is this console.log statement, where it is basically telling us the counter.address, which is the contract address once that is deployed, right? Also, we'll be adding few more. Say few more scripts within the package.json. Now, this is basically part of the hard hat configuration, so you can easily get that out on the. The hard hat website as well. However, I will quickly add these two. So one is basically for the local testnet configuration, yeah, that's it. So let me do that. And okay, so this is done. So this is how our updated package.json looks like. We have the Solidity coverage report and these basically 5 scripts. So now what we'll do is we'll go ahead and we'll run, say, npm run, say local, say -testnet, right? So this is basically this. So what it is going to do is it is basically going to, start a local Ethereum network for us and print out all existing accounts, including their private keys. So these are basically going to be, test accounts. So once I run this, okay, so here we go. We have around, say, 20 test accounts that we already have. Now what we'll do is we'll switch back, or maybe we'll go to the another terminal, right? So let me open another terminal. Okay, so just a second, let me open another terminal. And what we'll do is now we'll go ahead and we'll deploy this. So npm run deploy local, and so the script is running. And what it will do, so the compilation happened and it deployed this contract. Now if you go ahead and zoom in, so this is what our contract address looks like, right? So counter will deploy to this. Now how to use this contract and how the deployment happens, how to use this contract address, and especially how to use this API, and how to go ahead and maybe integrate this counter application to a web frontend with say increment button, and see how the data gets updated not only in the blockchain but how do we handle it in the front end. This is something which we'll discuss in the next video. Thank you everyone.